Hi, welcome back to this channel. In this video, we're going to start with another new chapter, which is the amine. In this video, we're going to cover two subtopics: introduction to amine and nomenclature. So basically, we're going to learn about how to draw, classify, and also name the amine. Due to amine is the derivative of ammonia, therefore it have the basic property similar as ammonia and also able to act as the nucleophile due to the presence of lone pair electron. So the functional group for the amine is this amino group NH2. Okay, basically you will see one nitrogen and then bonded with another 3 bonds. There are two types of amine. One is aliphatic amine and then another one is aromatic amine. So basically for the aromatic amine, the nitrogen will attach directly to the benzene ring. Okay, without wasting the time, let's start with tutorial question number 2. Draw the structure, and then later maybe we also can try to classify. 2-propanamine, so will consist of 3 carbon. Second carbon will attach to the amino group, so CH3, here need another 1 bond, here need 3 bond. So this amine, the nitrogen is bonded to 1 carbon only, so this one is primary amine. Okay, B, we have benzoic acid as the parent, so we draw the benzoic acid first, COOH, and then the third carbon will attach to the nitrogen, NH2. Okay, so in this case, again, the nitrogen is bonded to 1 carbon, so it's primary. And then at the same time, the nitrogen is bonded to the benzene ring, so it is considered as primary aromatic amine. Third compound, aniline. So this is the structure for the aniline as the parent. Benzene ring attached to NH2. Okay, however, here we can see there is another substituent will bonded to the nitrogen. We have N-butyl, which consists of 4 carbon, CH2, 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 CH3, and then another one N-ethyl, 2 carbon, CH2, CH3. So for this one, the nitrogen attached to 3 carbon, so tertiary, and then nitrogen attached directly to benzene ring, so it's tertiary aromatic amine. Okay, now let's proceed with tutorial question number 1. We need to name the amine, then also try to learn how to classify the amine. So first carbon, this one has the longest carbon chain, consists of 3 carbon, and then the amino group attached to the first carbon, so this one will known as 1-propanamine. So second structure, we have 2 groups. This one is the straight chain, and then this one is a branch. So this branch will become the substituent and known as isopropyl due to have 2 CH3. And then this one here, first carbon, second carbon, third carbon. So we will know this as a 2-propanamine because the nitrogen attached to the second carbon, 2-propanamine. And then the isopropyl is attached to the nitrogen, so N-isopropyl, 2-propanamine. Okay, structure 3, we have a C6H5, means have a benzene ring attached to carbon, and then hydrogen, CH3 and CH2 and H2. So the longest carbon chain in this case, which consists of the nitrogen, is here, carbon 1, 2, and 3. Okay, so with this, then we know this one, the parent name will known as propanamine. Okay, propanamine, and then this propanamine, the amino is attached to the first carbon, so it's 1-propanamine. And then this is the substitute which attached to the second carbon, and this substitute will known as phenyl, so 2-phenyl 1-propanamine. Okay, the fourth compound here is this. The parent is the aniline. So we write the parent name aniline. Cl is attached to the second carbon, so it's 2-chloroaniline. So if you don't want to use the number, then we also can use O, which is auto, and we present the position of 1 and 2. Okay, so the the fifth one here is the also aniline, and then here we have propyl, and also we have ethyl. So for this one, E comes first, so it's N-ethyl, and propyl, and then aniline. Okay, so after we do the naming, now let's classify. So this one this nitrogen only attached to one carbon, so primary. However, this nitrogen attached to 2 carbons, so it's secondary. This nitrogen attached to 1 carbon, so it's primary. So for the fourth and fifth structure, the nitrogen are bonded to the benzene ring, so both of them are aromatic amine. Okay, so after that we need to consider this nitrogen bonded to 1 carbon, so it's primary aromatic amine. This nitrogen bonded to 1, 2, and 3 carbon, so it's tertiary aromatic amine. Okay, tutorial question number 3. Draw the structure for primary, secondary, and tertiary amine with the formula C3H9N. Okay, so we do the first part first. The nitrogen consists of 3 bonds. But when we want to draw primary, it means that only 1 bond will bonded to the carbon, and then this time must consist of 3 carbon. Okay, so this is hydrogen, CH2, CH2, CH3. So let's check the number of hydrogen, 3, 5, 7, 8, and 9. Okay, so number of hydrogen is enough. So this is the primary amine. So now we proceed to the secondary amine. Nitrogen has 3 bonds. 1 bond is hydrogen, and then another 2 bonds must be bonded to carbon. Since here we need 3 carbon, so we separate to 2 parts. So one part will have 1 carbon only, and then another one will have 2 carbon. So again, try to check the number of carbon, 3, 5, 8, 9. So enough hydrogen. So the last one now we're going to draw is tertiary amine. So have 3 bonds. All these 3 bonds must bonded to the carbon. So CH3, CH3, CH3. So it's very obvious, already achieved C3H9N, tertiary amine. Okay, then now let's proceed to the second part. Choose appropriate amine that can be prepared from a nitrile. So as you still remember, nitrile consists of the RCN, and then only will undergo 2 reactions. One is hydrolysis, and then another one is reduction. Okay, so reduction of nitrile always will produce primary amine because we will add the H2 after the C and the N. So since then next we need to write the chemical equation. So we need to know there must be a CN, so already consists of 1 carbon. So means that there is another 2 carbon, CH3, CH2, CN. So undergo reduction to produce primary amine. So this primary amine this primary amine is produced when the nitrile undergo reduction. So if the nitrile undergo reduction, the common reducing agent that we use is lithium aluminum hydride in dry ether, followed by hydrolysis. Okay, so reduction of nitrile will produce primary amine. Okay, so in this video, we only focus on draw, name, and also classify the amine. So in the coming video, we will learn about the physical properties of amine. So that's all in this video. Thank you for your time and see you in next video. Bye bye.